Let's see, we are doing exponentials from 2 points. Level 1 pretty much means that there is a zero value or a starting point that they're giving us. So let's go ahead and just make sure we recognize that this is our zero value. All right, and what does that mean? Remember that this is the x value, this is the y value. I'll call that x1, y1 as our first point. Let's just label this one also. This is our x2 and y2. All right, let's go ahead and read the problem too. I don't want to jump too far ahead. All right, they're asking us to write what? An exponential function in this form right here. And it has to go through these 2 points. Okay, so remember exponential functions has a growth that has a common multiplier or a common ratio, sometimes they call it, but basically it's a growth through multiply or divide, depending on what kind of number we have. So it's always multiply, but it can be altered to make it divide. All right, remember what's what. All right, so we got our y value, we got our x value. Remember, x is input, y is output. And then the a is our zero value also. All right, and then our b is our growth or our common ratio or our multiplier, depending on what kind of problem they gave us. So they're telling us it's exponential. That means it's growing through multiplication. All right, so that means the zero value is this 5 right here. So that's our A. All right, now if we wanted to kind of look at it, and if you forget what to do, plugging your values in is a good way to start. So let's start off with our equation, y equals ab to the x. And remember, exponential function, that's where the x is. So the x is in the exponent. Notice that's where the x is, exponential function. All right, so if we just plug things in, because we're looking for a and b, those are our constraints. So a is, let's just plug things in. So the y is 5. And I'm just plugging, this is for x1, y1, first point. All right. So y is 5, a is what we're looking for, b is what we're looking for, and our x is 0. It's always good to remind yourself anything to the 0 is what? Anything to the 0 is always 1. So simplifying, this is 5 equals a times 1. And there's our 5 for our a value. So there's our 0 value. So a we got taken care of already. Now we just plug in everything else from the other point, including our a, and that leaves one unknown, and we can solve when we have one unknown. So let's go ahead and do that. Once again, we're using the same equation. So y equals a b to the x. We're plugging in the values from the second point. So the second point, y is 1, 2, 8, 0, 1,280 equals, we just found out a is 5. B is what we're looking for. That's our last piece. We're done when we have a and b and we've plugged them into the equation. Those are our parameters or constraints. And then x in this case is 8. Okay, so let's go ahead and start breaking things down. We solve for b. Reverse operations means we would divide by 5 first. So dividing by 5. Well, we do to one side, do to the other side. And I have my calculator right here. We got 1,280 divided by 5. 256. So this now becomes 256 equals b to the 8th. Okay. And how do we get b by itself? What's the opposite of the 8th power? Two different ways of looking at it, either the 8th root or 1/8 power. We'll go ahead and just do the 8th root. Remember, whenever you have an even exponent that you're undoing, there's a plus and minus involved. So let's go ahead and look at this. So in this case, we would go 2, 5, 6, and we got plus and minus, and we're looking at the 8th root here. So there's a little 8 in that crux. Equals 8th root. Okay, and that undoes it. All right. So in this context, we are talking about growth, so it's getting bigger and bigger. If we had a negative here, that kind of throws things off. So in this context, we are dealing with only positives. So we always want to just kind of write it down and then drop it due to logic or our constraints of the problem. So on the calculator, let's see, does your calculator have the 8th root? No, it doesn't. So in this case, let's go ahead and look at what it would be a little bit easier. All right, so that would be, remember I said it was the 1/8 power. So the 8th root is the same thing as the 1/8 power. So this is how you would type it in on your calculator. 256, so this is the same thing as 8th root to the 1/8 power. All right. Equals, and then we've gotten rid of the 8th power on the b. So we just have the b left. So we go ahead and type this in on our calculator. And 2, 5, 6, I got a feeling it's 2, but we'll go ahead and do it. Exponent key 1 divided by 8. And it is 2. Okay, and then we would just plug those last things in. Don't forget what we're doing here is we're trying to find the exponential equation. So that means our final y equals ab to the x would be y. So all of this means equals a is 5, b is 2, and x is our exponential function. Okay, let's go ahead and just plug things in. Y equals 5 times 2. I'll just go ahead and let's see, do I have any other times 2 exponent key right here, x, and let's just double check everything looks good. So let me just remind you of the process. In this case, they're giving you a 0 value. In fact, you can just plug in this value right here for your a and then just solve for b, undoing the operation. So that's going to be a more straightforward pathway. I just wanted to make sure you saw it and going through it. If it helps you to look at it in a table format, that's fine too. But everything looks good from this perspective. Got it. Okay, let's just go ahead and look at how they did it and confirm that everything looks fine. So they're just confirming what the a is, but like I said, you can just plug that 5 in this case. That's the 0 value. That's your x and your y. So x is 0. That means this is a y-intercept. It intercepts the y-axis. This is exponential growth in this case. And then we plug in that point, we solve it. They just use the 1/8 power, but it's good to know that 1/8 power is the same thing as 8th root. Plug things in and everything looks good.